Hello, everyone, and welcome to day 23 of the Jamb Physics in 40 Days series. To each and every one of you that has been part of the series from day one, we want to say a big thank you to all of you for always making it a date with us to join in the series. And if you're new to the channel, this is Jamb Physics in 40 Days, a series brought to you by Oyalen, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you should be able to gather all the necessary tools that will help you ace JAM physics. So if you are preparing for the JAM exams and one of the subjects that you have selected is physics, then this video is definitely for you. So you want to make sure that you check out every video from day 1 up until this day 23 and also till the end of the series. Trust me, you do not want to miss any of the videos in this series because what we have done is that in each of the videos, we look at the individual topics in the JAM physics curriculum, and then we go on to give you a crash course on it as well as solve past questions while giving you tips that will help you solve such questions with higher accuracy. So please, you do not want to miss any of these, and so for that you need to be subscribed to the channel, and you also have to hit the notification bell icon so that every time we put out a new content you will also be notified. So please ensure that you're subscribed, ensure you click the notification bell icon, and don't forget to like and share the videos as well. And if you have any question at all on what we are doing, or perhaps during your study you came across a question that you need help with, please put such questions in the comment section and we will definitely attend to all of your comments. And in addition to that, to ensure that your practice gets even better, you can download the Exam Fund app, and the link to the app is going to put in the description box of this video. So please click the link, download the app, register, and have fun while you learn. It's a very exciting app that makes your learning experience very much fun. So please download the app today, and trust me, you will not regret making such a decision. Now, to the business of day 23, what we'll be looking at in this video is light energy. Now, you agree with me that we've been looking at waves for a while now. That's because it's a really broad topic. But this aspect is going to be focusing on light energy. And what JAM expects of every candidate to know, especially when it comes to light energy, are listed here. Now, the first part is that you must understand your sources of light. Now, sources of light can be classified either as natural light or artificial light. Now, natural light are those sources of light that we find in nature. Like the sun, for example, is a natural source of light. Fireflies are natural sources of light. The stars, they are natural sources of light. So those ones are classified as natural sources because they exist in nature. Now, the ones that are made by man are what we call artificial lights, like the candle, the flashlight, the light bulbs, and the likes. Those ones are artificial source of light. So you should be able to classify among them. And then what other classifications include what we call the luminous light and the non-luminous source. It is luminous source of light and non-luminous source of light. Now, the term luminous means it produces its own light. Say, for example, the sun, candles, flashlights, light bulbs, they produce their own light, so they are luminous sources of light. Whereas there are some that do not produce their own light, but will rather reflect the light produced by another source of light. Like, for example, the moon. Now, I believe by now you should know that the moon does not produce light at all. But what it does is that when the sun's light is incident on it, it's able to reflect it to earth. That's what we see as moonlight. That is why you see that during the night time is when you see the moon. It is actually there even during the daytime. But the reason you are not seeing it is because the light from the sun is brighter than what this moon can reflect to you. That's why we do not see the moon during the day. But at night, when the sun is away from us, we are able to see the reflection of the sun's energy because of the moon. So it does not produce its own light. It is a non-luminous source. Another example is in the case of the traffic signs that we see. Now, if you travel at night, you see that it's easier for you to see traffic signs like the speed limit and the likes along the road. This is because they are made with special materials that reflect light back to you. So once the light from the headlamp of your car incidents on it, it's able to reflect it back at you. So it looks as if it is producing light, even though it does not produce its own light. It only reflects the light that is incident on it. So those are also non-luminous sources of light. Now, after looking at sources of light, they also expect that you should understand the propagation of light, and these are the aspects you should focus on this topic. You should understand speed, frequency, and wavelength of light. And I did mention in one of our videos that when we are talking about light, the speed of light is often denoted as c. All electromagnetic waves have the speed of light, which is approximately 3.0 multiplied by 10 raised by 8 meters per second. This is speed of light. And you should be able to relate this with frequency and wavelength. That is C equals F lambda. This will be the equation in this case. But remember that when we're working with other waves like the mechanical waves, we did use V equals F lambda. So the only thing is that we have substituted V with C, where C is speed of light. The equation still holds like this. Now, another thing you should also know is formation of shadows and eclipse. Now, whenever you put an object in front of a light, it blocks the light from going through. So as a result, it creates a dark spot known as shadow. Now, this makes us understand that there are different types of objects. We have what we call the opaque objects. We have what we call the translucent. And then we have what we call the transparent. Now, there's a common error among students when it comes to defining this. They often say that opaque will block all the light, transparent will allow all the light, and then translucent will allow some of the light. No, it is not true. Opaque, yes, would block light, but doesn't block all the light. But it blocks a majority of the light that is incident on it. So please get this right. Light is able to pass through even opaque objects. It's just to a certain degree. Now, to give you a good example of that, consider the X-ray, right? When you are put in front of an X-ray and the light passes through you, it is only stopped by your bones. That is why when you take an X-ray of yourself, you are able to see your bones. That's because your bones stop the light from passing, but it was able to pass through your flesh. So you see that even opaque objects, light pass through them to a certain degree. But what considers something to be opaque is the degree of light that passes through it. So if it is able to block most of the light that is coming at it, then such an object is opaque. However, if it is unable to block most of the light, that is only a little is blocked, most of the light passes through it, then in that case it will be called transparent. And then when we say it's translucent, it's more like a 50-50 case. I block some light and allow some to pass. So it's just the middle term for opaque and transparent. It's just in between both of them. So I believe you understand what this means now. So please don't get that twisted. It's simple. You just have to remember that there are different kinds of light source and every object blocks them to a certain degree. That's just the keynote in that case. And then finally, you should also understand how to solve problems with the pinhole camera. Now, most of the things that we usually find, especially with Jamb, when you're solving problems like this, is you have to understand the relationship between magnification of a pinhole camera and then distance of objects and the height of the camera. So, and there are two equations you must bear in mind. You should know that magnification actually is image height divided by object height. This is the general equation for magnification. Then when it comes to a pinhole camera, the same magnification is given as height of camera over distance of object. So because these two denote magnification, we can use them to solve for magnification. That means we can equate these other two sides of the equation too. So depending on the information you are given, you could be asked to find image height, object height, height of camera, or distance of the object from the camera. Now, these are the things that you should know before the exam on this topic. Now, for a better knowledge on this topic, I would advise that you check out our video where we actually explain light energy in greater detail. Now, this video is made for the purpose of prepping for Jamb exams. But for a full knowledge, you should check out the other video where we talk about light energy in detail. That way you'll be able to understand every concept that is under this topic, right? But for now, we'll just be moving from here to solve some past questions from Jamb, but also pay attention because we'll be giving you some tips that will help you arrive at the correct answer most accurately. So if you're ready, get your materials and let's solve some problems. This question says the pinhole camera produces a less sharply defined image when when you consider a pinhole camera, it does not require lens, right? So the principle upon which it works is that light travels in a straight line, right? So when you have a narrow pinhole camera, it will make the light be less condensed at that pinhole, hence producing a sharper image. So that is, the narrower the opening of the pinhole camera is, the sharper the images it produces. So another way we can put that is that you can also work with illumination, because when the pinhole is very narrow, it will limit the amount of light that passes through it. So lesser light will pass through, which will then give you a sharp image. So there could be two answers to this. You could be talking about the wideness of the pinhole or the amount of light coming through. Both of them are saying the same thing, only a different perspective. Okay, so in this case now, there are two answers to really focus on. We have A saying pinhole is larger and B saying illumination is less. So you see that when the illumination is less, it should be producing a sharper image. But when the pinhole is large, the image produced will be blurred. So our answer here is option A. However, you need to understand that if you don't have pinhole is larger as an option, but you see illumination is more, then in that case also it will produce a blurry image. So that's just what to look out for. But based on what is here, our answer is A. Let's take a look at this question. It says lamps in domestic lighting are usually in, and then we have four options here. We have series, divergent, convergent, and parallel. Now let me break this down to you. So I'm going to break it into groups of two. In the first group, we're going to be having series and then parallel. While in the second group, we're going to be having divergent, and then we're going to be having convergent. Now, why have I divided into this group? So please pay attention. The way a question is set will most times help you to know what the examiner really requires of you. In this case, we are discussing light energy. So it's easy to know that I'm asking about whether it is divergent or convergent because you are looking at the beam of light. So in this case now that we're just looking at the type of lighting source that we are using, whether it produces divergent beam, convergent beam, or whatsoever. Now you look at these two and then see which one is best for a domestic lighting case. Now in the house, you would want the light to cover more area, right? Now look at this. This is what convergent light does. If this is the light source, a convergent light source will bring all the beam to a narrow end, like so. This would be convergent. But a divergent beam, if this is our light source, will produce the light scattered across like this. So you see that in the case of divergent, you're going to cover more area with the light. And this is how the lights in the households are created, so that they can cover more space and just one light can serve the purpose of two or three, right? Just in one spot, it will cover a large area of space because of the divergent beam. That will make the answer in this case B. However, if the question is set from the aspect of electricity, Like if you are seeing the question including things like current or voltage as part of the way the question is set, you see in this line of question there's nothing about current or voltage. That is why it's easy to pick our answer as divergent. But if the question carries something that involves either current or voltage or resistance, then you see that they are asking from the aspect of electricity. Now, in the household, when you are doing the wiring for your lighting, it is best done in parallel. That way, you're not going to be using so much resistance as such. And then the most important part of it is that when one of the lights goes out, it does not affect the others. If it were in series, if one should have problem, every other light that comes after that one will not receive electric supply, right? But in parallel, all of them have their own source. The same voltage runs through all of them. So if one of them is faulty, it's only that one that goes off, while the others will remain on. That is why in your household, if one of your lights goes off, it's only that one that goes off. So you can then replace that bulb to a new one. But if they were in series, if one should go faulty, it will affect the rest that comes after it. So if it is from the aspect of electricity, we would have gone with parallel. But because this particular question is set based on the light source only, that is why we are focusing on whether it is divergent or convergent, which gives us our answer as divergent, option B. Shadows and eclipses result from the reason why we have shadows and eclipses is because of the theory which proves that light travels in a straight line. So if this were a light source, for example, light coming out of it will all travel in a straight line, like so. I believe you understand the concept at this point. And then if you should have an object that is opaque in the line of the light that is coming, it will block that light, thereby creating a dark shade behind it, which we know as shadow. And this is the same concept that happen in the case of eclipses. Like what we call the solar eclipse means that you have the sun, and then the earth, and then the moon. So let me put the moon in the middle here, and then the earth, like so. So because the moon stands now, this moon is considerably smaller anyways, so don't mind my drawing. So when the light energy coming like this touches the moon, it blocks it. So the only thing that comes off are these ones that are coming from the edges like this that touches the earth. So this blocks some part of the sunlight that is supposed to reach earth. So as a result, some people on earth will be seeing a dark shadow as if something is covering the sun completely. While those at this point we only see it partially and the likes like that. But it all focuses on the same thing, that light is traveling on a straight line and it is going to be stopped by an opaque object. Now that theory is discussed extensively in the rectilinear propagation of light. You see cases like refraction of light, this one focuses on when light is traveling from one medium to another of different density, which causes the light to bend. The velocity will then change just as much as the wavelength will change, but frequency remains the same because that is determined by the source of the wave. And then for reflection, that is the law that states that when light is incident at an angle, it's going to be reflected at the same angle, provided it is a plane surface, right? And then we have C, which is diffraction, that is light passing through a narrow gap and then spreading out from that small gap. These three are talking about something a bit different, but this is the one that truly explains what we know as shadows and eclipses. So the answer in this case is option D. Let's solve this problem which says calculate the height of the image formed by a pinhole camera of length 12 centimeters used to photograph an object 60 centimeters away from the hole and 70 centimeters high. Don't forget that if you have any question at all or if there's anything you come across while you are studying that you would like help with, please put it in the comment section and we'll definitely attend to every one of your comments. And also please keep liking the video and don't forget to share as well. And if you're not subscribed to the channel, please just take a moment and click the subscribe button and also the notification bell icon so that you get notified every time we put out a new content for you. So to solve this question, this is what we're going to do. Solution. We're going to equate the two equations for magnification. Now, magnification is image height. Let's call that H. Okay, let's just write straight. Image height over object height. This is magnification. And it's also the same thing as the height of camera for pinhole cameras, okay, over the distance of object. So let's apply this to solve for image height. So from here, the image height, let's call that H, over the object height is 70 centimeters. Now we equate this with the height of the camera, which is given as 12 centimeters, all divided by the distance of the object, it is 60 centimeters away. So centimeter here cancels centimeter. So H equals 70 centimeter multiplied by 12 all over 60. 0 cancels 0. 6 here 1, 6 here 2. So we have 7 centimeters times 2, and that will give us 14 centimeters. So the answer to this question is option D. This question says, if the distance between the object and the pinhole camera is reduced by half, the size of the image will... So let's find what happens to the size of the image. Now we know that magnification is image height over object height, and the same magnification is height of the camera over distance of object. So when we equate these together, so image height over object height. Now equating this with camera height and distance of object. Now considering this, by the time you alter the distance of the object, reducing this by half, when you reduce this by half, that is 1 over 2 of this, would actually take 2 to this part. That is, that will make that the object height would be doubled by the time you cross it here, right? By the time you cross that here, what's that going to mean? That means our image height would be doubled. So by the time the image height is doubled, that means our answer in this case is option D. This question says, if the distance between the object and pinhole camera is reduced by half, the size of the image of the object. So we're going to find what happens to the size of the image, that is image height. Now what we know is that magnification equals camera length or height over object distance. Right? So in this case, by the time you reduce this distance by half of it, what is going to happen is that the magnification gets increased. So if magnification is increasing and then you relate the same magnification to image height over object height, what happens is that since magnification is increasing, image height should also increase. So as a result, since you are reducing object distance by a factor of half, magnification will be increased by a factor of 2, and the same thing will happen to image height, which will be increasing by a factor of 2. So that means it's going to be doubled. So the answer in this case is option D. Which of the following is not a luminous object? And you can take a second to answer this because we've mentioned this at the beginning of the video, that luminous objects are those that produce their own light, right? And if you consider all these four options, a star will produce its own light, a candle will produce its own light, the sun will produce its own light. However, the moon only reflects the light from the sun. That makes it a non-luminous object. So I believe that should be your option as well. So we are going with B. In this question, we see that a motorboy of a driver saw what seemed to appear to be a pool of water ahead of him while the driver drives a new truck on a funny day. Now, which of the following explains his observation? Now, this kind of sighting is what is called in physics a mirage. M-I-R-A-G-E. Now, the conditions that makes a mirage to appear are this. One, light has to be traveling from an optically less dense to an optically more dense region. So that is when it's moving from hot to cooler air, what you experience there, that is one of the conditions for a mirage to occur. Now, the second thing is that the angle of incidence must be greater than the critical angle. So when these two situations come together as one, they create what we know as total internal reflection leading to mirage. Okay, so what this motorboy is saying is a mirage. It is not actually real water, but it's due to total internal reflection because the sun rays is moving from a less dense to a more dense medium. So in this case, the answer would therefore be option D, which says the sun rays move from the sky. The sun rays from the sky were passing from a hot air layer to a cold air layer. So that's option D. The direction of the path taken by light is called. Now, when you have a light source producing light, we know that light travels in a straight line. So that line that shows the direction and path of a light is known as a ray. So this, what you see here in diagram, is called a ray of light. And you see it shows the direction, that is the path of a light. So when you have a collection of these, like two or more, is what we now call beam of light. So this will be called a beam of light. And we know that there are different types of beam of light. We have parallel beams, we have converging beam, we have divergent beam. And I think that's about the types of beam of light. So since this question is only looking at the path taken by light, we're going to be focusing on ray of light in this case, which means the answer is option C, which says ray. An object is placed 10 meters from a pinhole camera of length 25 centimeters. Calculate the linear magnification. Now, one thing you need to first take note in this question is that we have them in different units. So when you're solving, you either bring this to centimeter or you bring this to meter. Whichever way it works, just make sure they are in the same unit when you're trying to solve for the linear magnification. So here will be the solution. The linear magnification M is going to be given by the length of the pinhole camera, which is 25 centimeters, written as 25 times 10 raised to power minus 2 meters, all divided by, now we have the distance of the object from the camera, which is 10 meters. So you see meters cancel meters, and 25 divided by 10 would give us 2.5, and this is times 10, and the power here is still minus 2, so let me just write this well. So times 10 to the power of minus 2, that will be the magnification, and that is option B. In this question, it says the particle nature of light is demonstrated by the. Now, when we look at light, We know light to be a wave, and that is what it has always been for a very long time, until what we now know today as the photoelectric effect. You see, when light is incident, especially on metals, what is observed is that they tend to knock off electrons from the shells of such metals, leading to what we know as the photoelectric effect. Because when those electrons are collected in a current, it produces electricity, right? That is production of electricity by beaming light onto a metal surface, right? So that is the photoelectric effect, and it is credited to Albert Einstein. So when we're looking at the particle nature of light, that tells us that light has a duality. We can consider it a wave, and we can also consider it as particles known as photons, right? So the particles of light are called photons, and that is explained by the photoelectric effect. So the answer in this case is option A. If you're yet to be subscribed to the channel, let me take this moment to please implore you that you hit the subscribe button, because for as many of you that are subscribed to the channel, we get enough to be able to help us continue to make more helpful videos like this. And trust me, we really want to continue to make this kind of videos. So please subscribe, and as you share the video content, also ask those you share it to also be subscribed to the channel. So please, not just like, not just share, but also subscribe, and then you can hit the notification bell icon so that you get alerted every time we put out a new content. And don't forget that we are here for you. So if you have any question at all that you would like to ask us, if you need our help on a question that you are solving perhaps, you can also drop that in the comment section, and we promise to attend to every one of your comments. Thank you so much. Now, to look at this question, it says that the eclipse of the sun occurs when? Now, it is not very specific, and when we look at the options provided, we can easily knock out option B and C, because option B is saying Earth is between the sun and the moon, and that is what occurs for lunar eclipse. That's the eclipse of the moon. When the earth rather is between the sun and the moon, the earth's shadow is going to be cast to the moon, and that is called the lunar eclipse. And then option C is saying the moon is not completely hidden in the earth's shadow. This is partial lunar eclipse. Now, back to A and D, which is what we are left with now. Now, for context sake, it's important that I explain this. When we say solar eclipse, it just means that the moon is between the sun and the earth. That is, the moon, which is an opaque object, is blocking the sun rays from reaching the earth fully, right? So that would be a case for solar eclipse, and that makes option A the correct one in this question. However, if you are given a question where you are asked to describe total solar eclipse, in that case, it means that some regions of the earth is completely blocked from the sunlight by the moon. And for that to happen, it means that that region on the earth must fall within the umbra of the moon's shadow. Now, if you recall, in shadows, there's something called the umbra and there's something called the penumbra. Now, for the umbra is where there is total darkness. There is no light passing through at all at that point. But penumbra, there's a little bit of light there with the dark shadow also mixed together. So at those parts, they will still see the sunlight a little bit. So it's going to appear to them as a partial eclipse. But those who are at the umbra region will receive a total eclipse. And you agree with me, because during the time when we experience total solar eclipse in some countries don't get to see the eclipse at all, while some see it as a partial eclipse. That tells you that some fall in the umbra, some fall in the penumbra, some fall out of the shadow completely. So if the question was about total solar eclipse, I would have picked option D. But because the question is not specific, it only asks that the eclipse of the sun occurs when, so that is, it's not specific to total solar eclipse. So that makes option A the logical answer in this case. So we go with option A. In this question, we have some things to verify. The first one says total internal reflection of light. The second statement is conservation of light energy. The third says relative motion of the earth, sun, and moon. And then the fourth says rectilinear propagation of light. That is, light travels in a straight line. Now, the question that follows now says, which of the above is a phenomenon of total solar eclipse? Now, for solar eclipse to occur, it means that the light traveling from the sun is being blocked by a celestial body, which is in this case the moon. So when the moon blocks the light from the sun from reaching the earth, we can experience what we call the total solar eclipse. In some regions of the earth where the umbra falls, that's the part that experiences the total solar eclipse. And that is explained by rectilinear propagation of light, which says light is traveling in a straight line, and so it is blocked by the opaque object, which in this case is the moon. So we know that 4 explains that. And then the reason why this is periodic is because we see that the sun, the moon, and the earth are always moving relatively with each other, where the sun is rotating about its axis and at the same time revolving around the sun. And we also have the moon doing the same to the earth. It is on its own axis also rotating but also revolving around the earth, even though it is localized to the earth because of the earth's gravitational pull. And even the sun itself is doing the same as it goes around the black hole in Milky Way. So we see that this relative motion continues and on like that throughout the observable universe. So that tells us that the relative motion can also explain this, because there will be a time where the moon will then revolve rather, and come in between the sun and the earth, thus leading to the total solar eclipse. However, conservation of light energy does not explain this just as much as total internal reflection does not explain this. Total internal reflection may explain things like mirage, or why fishes can see in all directions, and can also explain what is used for to view the outside from a submarine, where they use the effect of total internal reflection also, helping those in the submarine to see around them when they use their equipment, right? So, but they do not explain total solar eclipse. So leaving it to just 3 and 4, and that means the answer is option D. Non-luminous objects can be seen because they, now I did explain this at the beginning of the video when I was talking about classifying different types of sources of light, and I said non-luminous objects do not produce their own light. So what they do is they reflect the light from other sources of light. Like the moon, for example, is non-luminous, and it does not emit its own light, but instead reflect the light of the sun to the earth. And the same thing applies to signposts by the roadside. You see that they glow at night. It's not because they produce light, but they reflect the light from the headlamps of the car back to the driver. So non-luminous objects can be seen because they reflect light. So the correct answer here is option A. Radio waves emitted from an antenna are picked up by a radar after reflection from an aircraft in 4 times 10 to the minus 3 seconds. Now, how far is the aircraft from the antenna? So in this case, it means that we are not looking at the entire round trip, but just looking at half that distance. Okay, so the solution here would be, if they had asked for the distance, the entire round trip, I would have just multiplied the speed and time to give us distance. But since it's just between the aircraft and the antenna, it means it is half of that. So the distance would then be the speed of light, 3 times 10 raised to the power 8 meters per second, multiplied by the time, which is 4 times 10 raised to the power minus 3 second, all divided by 2. So it just looks like the same way you solve problems if we're using echo to find distance. So in this case, what we're going to do is this times this will give us 12. 12 divided by 2, and we have 6. So 6 times 10 raised to the power 8 minus 3, that is 5. And this is in meters. So to bring this to kilometers, we would have 6.0 times 10 raised to the power. Now subtract 3 from this, that will be left with 2. And this is in kilometers. So 6.0 times 10 raised to the power 2 kilometers is what we have in option A. The image in a pinhole camera is Let's look at what happens to the image formed in a pinhole camera. So let's say this is an object and this is the pinhole camera with a small opening. Now the rays coming from this part goes like this in this direction. Let's pick another one like that in that direction, and then this comes like this, and similarly this comes like this, all in their specific direction, which will then produce the image in this form. So we see here that rays are going to come from every part of the object, and when they get in the camera they are inverted, so the image is inverted and the rays come from all parts of the object. So let's see the option that matches that. Option A says erect and formed by refraction through a lens. Now there's no lens involved at all in this case, so option A is obviously wrong. Now B says it is virtual and formed by dispersion. Now dispersion is only concerned about when light splits into its component colors when it passes through a prism, like the formation of rainbow and things like that. So that is also wrong. Now C says it is erect and gets sharper as the hole becomes larger. Now first things first, when the hole becomes larger, it's supposed to be blurrier. To get it sharper, it's supposed to become smaller, so that already makes it wrong. And of course the image is not erect as well, so both statements in option C are wrong. That leaves us with option D, which says that it is inverted, and we say it is inverted, and then it's formed by the light from each point traveling in a straight line. And all these lights coming from each point of the object are traveling in a straight line to form the image as well. So the correct answer to this question is option D. Now, to get in more practice, let's introduce you to an app that makes your learning experience a whole lot more fun. Please click the link in the description box of this video to download the Exam Fun app. It helps you make your learning time very fun as you solve questions on any subject of your choice at different levels while getting points and also earning as you solve questions. So please click the link, download the app today, and I promise you, you're going to enjoy your experience. You have never experienced this type of learning from any other app produced before. So please try Exam app today. And also do not forget to subscribe to the channel. It's only going to take a moment of your time. Just click the subscribe button and hit the notification bell icon as well, so that you get alerted every time we put out a new content. And also do not forget to share the video. Let's help as many as we can by sharing the video across all our friends, so they too can have access to this helpful content that we are here making. And don't forget to like the videos as well. And in case you have any question at all you would like to ask us, perhaps maybe during your study time you came across a question that you would like some help with, you can drop that question in the comment section. We will definitely attend to every one of your comments. Please keep the comments coming. Thank you so very much for following the series so far. It's day 23 already and the series continues on. So please, I would like to see you in the subsequent videos. So thank you so much. Don't forget to share the video. I'll see you in the next video.